Hello, everyone, and welcome to this MarineData4Asia webinar. Today is our practical session. Yesterday, we gave you an introduction of the Copernicus Marine Service. We had really interesting presentations about the products you can find in the Copernicus Marine Service to support environmental studies, marine environmental studies in the region of Asia. And today we will dive a little bit deeper into how to access the data, how to visualize it, and how to manipulate it or how to handle it in Jupyter and in QGIS. My name is Andrea Carvalho. I'm a training officer at MarineData4Asia2024 International, and I'll be your host for today. Before we start, I would like to show you how you can access all the information related to this webinar. I hope you had the time already to explore it a little bit. When you enter the page related to this webinar, you will find some general information, the agenda, and then you will also find dedicated pages to the practical sessions. With the tutorials that were especially developed for this workshop. Today we will have more information about that, how to access them, how to download it, and how to play with the data. Yes, we will continue to feed this page, and we will also include the recordings of yesterday's session and today's session in this the same page. So you will be able to rewatch it and to practice whenever you want. So before we continue and start today's session, we will give you some guidelines for better to better enjoy this session. So first of all, once you enter in this page and you're following the live stream, you will need to set up your audio if it's not automatically done. On the bottom left corner, you will find the symbol you see here on the screen. Just click it and you will be able to hear us. If not, just if you're having any technical issue, you can use the chat on your right-hand side, and we will be able to help you with that. You can also use this chat for small talk if you want to say something to us. But if you have any specific question related to a presentation, if you want to ask any question to our speakers directly about what they are going to present today, please use the Q&A tab. You will see at the top bar of your screen, and there you will be able to post your questions, and we will address them at the end of each presentation. And I think that's it for the guidelines. Don't hesitate if you have any question. We'll be here to help you. Now I will introduce you to our program for today. We will start with Leila Fabre. She's a user support officer at MarineData4Asia International, and she will do a presentation of the MyOcean Pro viewer. Then we will have Álvaro de Pascual Collard and Stefania Ciliberti from No Login. They have developed the tutorials, the materials, the practical materials you are able to find already in our events page. And they are here to answer your questions. They will tell you a little bit about these practical exercises, and hopefully you have some questions for them. This is the moment to ask them. Great, and I think that's it for the guidelines and agenda. So I think we can start with our session. I will give the floor to our first speaker, Leila. Whenever you want, the floor is yours.
So, hello everyone. Today I will introduce you the MyOcean Viewer. It is accessible from the Copernicus Marine Service homepage by clicking on Ocean Visualization. We offer 3 types of visualization tools: MyOcean Learn for beginners, MyOcean Lite for intermediates, users, and MyOcean Pro for experts. And today the presentation will focus on the last one, so we are going to explore it. Right now, you can see a map in which are displayed two default layers, the seawater potential temperature and the mass concentration of chlorophyll A in the seawater. When you are on the map, you can move around, you can zoom in and zoom out by scrolling. You can change the projection by clicking here. With the bar at the bottom, you can change the dates that is displayed. Right now, the 28th of January 2024 is displayed, but if I want to change the date, I can zoom in on the bar by scrolling and select another date. For example, this date. You can see that the map was updated, and with the left and the right arrows, you can change the date like this. With the bar on the right, it's the same thing, but for the depths. So I can zoom in, choose another level of depth. You can see that the map was updated and it shows the bathymetry. On today's presentation, we will focus on Asia and more specifically on the Kuroshio Current, also known as the Japan Current. It's a strong current that flows along the coast of Japan. And to observe it, we are going to check the velocity of the waters. So we are going to choose a new layer. And to do that, we click on Add Layer. This gets us to the Copernicus Marine Data Store, in which almost 300 products are available. They are sorted by popularity, the product recently viewed, the new product, and some other categories. If you want to filter your search to find a product, you can click here and type in a keyword. For example, if I type temperature, I will get 129 products, including temperature data. The other way you can filter your search is by selecting the different parameters on the left. You can choose the time range, the depth range, the universe, the variable you want to see in your product, the area of interest, the temporal resolution. You can choose the source. So if you want a product created from a numerical model or from in situ observations or from satellite observations. For this presentation, we are going to select the variable velocity. Because we want Asia to be included, we're going to choose the global ocean as an area of interest. And for the resolution, we're going to choose a daily one. We are now down to 9 products. Under each product, you have a short description. First, you have the name of the product that you can copy to your clipboard by clicking on it. You have the way the product was created. You have the spatial resolution, the temporal resolution, and some of the variables that are present in the product. You have the possibility to add your product to your favorites, and you will retrieve it here. If this short description is not enough, you can click on the product, and this will get you to the description tab. Here you have a short overview. You have some use cases so that you can see how the product data can be used. And you have the metadata here. It's a longer version of the short description we saw just before. Here you have all the variables that are present in the product. Under this tab, you have the notifications tab. Here I've gathered all the information you need to stay updated on the product. So there are general news, incident, improvement, and maintenance notification. In the data access tab, you have all the data sets displayed, and you have the ways you can download them. So with the subset service, you can graphically subset data in time, space for one or several variables. With the file browser, you can download original files. So you just have to select a year, a month, and you just have then to download the file for the day you want to see the data. And then you have the, the map service. With it, you can visualize your data in tools like QGIS, for example. Under each service, you have the information icon. So it will redirect you to a useful article from our help center. If you want more information about the product, you can check the product user manual, which is a technical document, or the quality information document, which is a scientific document. You will most likely find the information you're looking for in these documents. But if it's not the case, you can contact us here through our chat here. So for this presentation, we are going to choose this product. We click on Add to Map, and we are going to select the layer we want to display on the map. I said that I wanted daily resolution, so I choose this dataset with the D letter, meaning daily, and I choose the layer seawater velocity. I add it to the map. So right now you can see the layer was added here. You have the possibility to hide a layer by clicking on the eye to show it. You can change the priority of a layer like this, and you can delete a layer by clicking on the cross. Here on the map, you can see that the Japan current is in dark green like this. I'm going to show you all the functionalities you can use on My Ocean Viewer. I'm going to start with the functionalities on the left. The first functionality is the download button, but I will show you that at the end. You have the information button to retrieve the information about the product. You have the possibility to change the product layer. You can choose another one very quickly like this. You can customize your map. For example, you can choose to change the opacity of the layer. You can change the color of the map. You can invert the color map. You can create a discrete color map by clicking on the steps, and then you can choose the number of steps like this, and you can customize them here. You can decide to mask out of range values. So the range is here, and if I change it to this range, all the values that are not in this range will disappear if I click here. They're not in the map anymore. With the auto button, you can increase the contrast like this. It analyzes the data currently visualized, and it selects the appropriate min and max values. With some layers, you have the possibility to change the style and to display the vectors. So right now, you can see that the solid is displayed, but you can add the vectors. You can see all these arrows showing you the direction of the Kuroshio current. And you can also decide to show the vectors only, like this. With some layers, like the velocity one, you can also decide to change the value scale to log by clicking here. Now I'm going to show you the other functionalities on the right. You have the possibility to create objects like points. Oops, okay, like points, like lines, and areas. You can see that for each object, graphics are created. So for the point, time series and a depth profile are created. For the line, a transect and a depth profile is created. And for the area, a histogram is created. You have the possibility to delete a graph here, or you can create new ones by clicking here. You can hide the graphics tab here. You can increase the resolution of a graphic like this, and you can download it to a CSV file. But you need to know that the CSV file is only a sample, see written here. Even if you increase the resolution, the temporal resolution will not correspond to the original temporal resolution. I'm going to show you that now. I don't know if you will see it, but if I open the CSV file, even though this is a daily data set, not all the days are available in the CSV. You have the possibility to share your work by clicking on the share button. You can share a link that will include all the layers, all the objects created, and all the graphics. You can create an image. You can create a video or even a GIF. And you can create a named link. For example, if you have a website, you will be able to display the map in it. In the settings button, you have the possibility to customize your map. First, you can log in and log out. You can change the way you display your map. For example, you can decide to show the toponyms so that the name of the marine areas are displayed on the map. You can change the projection and you can change the object units. Now I'm going to talk about the way you can download data on MyOcean Viewer. You click on the download button. You can, and the first way to download your data is to write your different parameters manually, but you can decide to click on define on map. Then you draw a shape and you will see that the coordinates of the shape are written here. You can select also a previous object you've created. So if I select this area, you will see that the coordinates are written automatically. You can change the date range. For example, if I want to change the end date, I change the date with the bar at the bottom, and then I click on Azimap, and you will see that the date has changed. And for the depth range, it's the same thing. I change the depth, I click on Azimap, and it's changed. Then to download your data, you can click on this button, the download button, or you can click on automate, and this will generate the commands you need to use on the Copernicus Marine Toolbox, either on the command line interface or on Python. And like I said before, you can use the browse file to download the original files from the dataset for the day of your choice. If you choose a layer, a dataset, sorry, with several variables, you can download several variables at the same time. This will appear, and you will have the possibility to select all the variables you need. In the viewer, there are shortcuts available. You can see them here in this information icon. For example, if I click on the Z button, all the tabs will disappear and you will see the whole screen. So this can be useful. And if you have a question about MyOcean Viewer, you can click on the chat icon. You will have the possibility to search an article. For example, you can check this article, Introduction to MyOcean Pro Viewer. At the end of it, you will find the Q&A with the most asked question. So maybe your answers will be in this article, but if it's not the case, you can come and ask us the question and we will answer as fast as possible. Okay, I'm done with the presentation. Thank you for your attention. Gael and I will answer your question if you have some. Thank you.
Thank you, Leila, for this super nice presentation. So you were able to see how you can visualize Copernicus Marine data using the MyOcean Pro. And we do have already a few questions. They might be a little bit general. So the first one, maybe I could go for it. So the first question is, oh, could you just stop sharing your screen?
Yes, sorry.
Yeah, no, it was a nice background image anyway. So as first question, yeah, that will be a little bit more general. If we coordinate with NOAA, so the National Oceanographic American Atmospheric Institute, right? We don't, I mean, Copernicus, not directly, but Mercator Ocean International, who's the entity responsible for the implementation of the Copernicus Marine Service, does have some implication with NOAA, but in other projects, not related to the Copernicus Marine Service. Yeah. So second question, maybe this one, I'm not sure if it is related to the viewer, but someone asked, I would like to open maps by GIS. Can I change them to be able to? Or the only way is in QGIS? So maybe if you would be able to use some of the maps that you get in the viewer to use maybe in a GIS software. I'm not sure what the question is here, but for example, could you open any of the maps we were able to see in the viewer in any other software? In a GIS sort of software.
If that is the question, yes, you can open any any maps with QGIS. We have multiple articles on this question, but yeah, I don't understand the question, maybe.
Yeah, yeah. Maybe if you could be a little bit more specific, the person who asked this question, we will try to address it later on. We will have a dedicated session for the QGIS software, so maybe that will be the moment then. Let me see if there's any. Wow, there's actually now a lot of questions popping in. Most of them are related to the recordings. Let me just remind you, we are recording this session, so you will be able to rewatch it in both our YouTube channel, the YouTube Copernicus Marine Service YouTube channel, but also in the website that I just showed you in the beginning, where all the information on this workshop is. You will be able to follow it there as well. And so, looking at if there's any other. Okay, do you have an example with the embedded map view of my ocean in a web application? Ooh.
Not
Yeah, I don't have an example with me right now.
not right now. But
Yeah.
I know it is used, but like that, no.
like an example
Yeah.
that, yeah. We can try to maybe put that in the Copernicus Marine Service page dedicated to the My Ocean Pro. Why not? We could add maybe a section of examples where it has been used. But it's true that we sometimes have contact also people asking how to do it, right? Like how to
Yes.
embed it in the website. So I guess in the end they did do it. Yes. Just scrolling through. There's one here. What a wonderful interface. If we have a continuous in situ data in an area, for example, temperatures, are we able to feed them into your system and visualize it? Do you have any information on that? Because I know it's a kind of a recent process,
Yes.
right?
Yes, it's in I think it's in progress. It's not available now, but it will be in the future. So yeah, the short answer is not yet.
Yes. Yes, that's also the information I have. The suggestion, sorry, it just takes me a while to look through. You have been putting some questions. That's really nice. What is your suggestion if I want to use the map for publication? Can I use directly from the ocean map viewer?
Because of the resolution, I would tell you to use the data, to download the data yourself and visualize it in another, how do you call that? Like in QGIS or something like that, because you will be able to have a better spatial resolution that in the viewer. The viewer is just to visualize data like quickly. So as Leila said, sometimes you will lose some days, something like that. So it's better to, if you want to download the data and visualize it with a greater resolution, it would be better to download the data directly.
Okay. Okay, thank you. Another one. Hi, I would like to know if it is possible to add a CSV file with points coordinates to add lots of points to Ocean View Pro.
I don't think that's a thing that is possible for now. If the question is you want to download data starting with the CSV file, it is possible. That is something we have article on this, but on the MyOcean viewer, I don't think it's possible.
No,
You
it's not.
maybe ask us the question and we'll look into it in more details.
Leila, did you want to say
Yeah,
something?
it's not possible to import a CSV or a shapefile for now.
At the moment, yeah, okay. Might be in the pipes.
Maybe
We
one
don't-
day.
Yes. Yes, we done. So, what is the purpose of adding more than one layer of variables? Is it possible to visualize a correlation of two layers of variables?
Yes, for instance, when you have the current, you can display it as a vector and then display maybe the temperature, chlorophyll, anything you'd like, and see the correlation between the two of them, or either change the opacity of one layer and change the color map to see maybe the correlation between the two. So I think, yeah, it's something that is possible.
You would have to play around
Yes.
with yeah, display settings, right? To be able to visualize it. Yeah, that's that's always a fun one to do. It's actually my favorite. Great. Maybe another one here. There's any browser limitation or browser special requirement to access the MyOcean viewer,
No,
as far as you know?
So, no.
I don't think there's a limitation.
No, right? It's quite easily accessible.
Yeah.
Yes, it's just if you want to download data, you'll have to be logged in, but otherwise to visualize, I don't know.
Yes, so that's a very important point. Like to visualize it, you don't need to register yourself in the Copernicus Marine Service, but to download data, you will have to do that first, and then log in into the viewer, right? And then you are able to download whatever you want. Great, and I think we are good in terms of questions for you guys. Thank you very much for your presentation and for your answers. That was really nice. Thank you. Okay, so now we'll move on to our next practical moment of the day. We will have Álvaro de Pascual Colar, who's gonna tell us about a very interesting tutorial he developed, and is gonna do a little bit of a presentation about it, maybe some demonstration. So this is related to one of the tutorials you are able to find in the page dedicated to this webinar. Hopefully you had time to look at it. If not, you will get a little glimpse now, and maybe later on you will practice. So Álvaro, whenever you want, the floor is yours.
Hi, good morning to everyone from Spain. Well, good afternoon for the people in Asia. Well, my name is Álvaro Pascual. I'm gonna share my screen. My name is Álvaro Pascual. I work in Login and Equator Systems. And this session and this speaker will explain a little bit about the Jupyter notebooks we have proposed as examples for this webinar. In these Jupyter notebooks, we are doing a fast analysis of El Niño Schroeder oscillation, also known as ENSO. And with these Jupyter notebooks, we will use Python code to analyze the ocean fields. Is this okay? Well, here you have just a short view of what are you going to find in this section in the Jupyter notebooks. Well, we will access the Jupyter notebooks through the web page of the course. I will explain this later, and we will work in the framework of Jupyter Hub. That is the platform where you can code your own your own material, and you can run cells, etc. It's very important for any user to know that the Jupyter code has to, the notebooks must be downloaded and copied to your home directory. So we will see how to do it right now. And because this is the first step, and it's a mandatory step. If you don't copy the material to your directory, you won't be able to run the material. Well, let's go to the material, clicking here. Andrea, can you see my web browser?
Yes, yes.
Yes. Thank you. Sorry, it was, yeah, just to be sure. Well, this is the web page of the course, as you can see, and well, you can access the Jupyter notebooks by clicking in this link here, and you will access this web page where you can find very different options. Here, there are some options to download the materials and some documentation to download the material and run the material in your own computer. It's very interesting because you can create an environment, a Python environment in your own computer and start to work with Copernicus data in your own computer. And well, as I said before, one condition to enter in the Jupyter Hub is to be registered in Copernicus Marine Service. I think if you are watching this tutorial, this video, you will have to be already registered, but if not, you can click here and go to register in the Copernicus Marine Service. And after that, here is the link to access the contents. And by accessing the contents, you can see there is a web page where you are asked for your credential of Copernicus Marine. You enter your own credentials here, and you can log in into the Jupyter Hub platform. It can take a few seconds, and well, this is what we have. A fast explanation could be that there is just a file browser here, and in the right side of the window, you will have the workspace, right? So as I said before, the first thing you need to do is to copy. Just to access the material is to copy the contents to your home directory. You will see that you are here in your home directory, and probably you will have different directories depending on what have you done in this context in your directory. So to copy the materials to your directory, you will have to open a terminal, and you will have to write copy from Jupyter notebooks training Asia. So excuse me, there is something here, -R. So with this is a Linux terminal. So this is a Linux command where we are asking to the computer to copy with recursive mode this directory to the directory where we are already now. So we can enter, and you will see. Okay. You will see that in your home directory appear this directory. You can close this window now. You can close this window, and you will see that directory. That is the directory where you will find all the contents and the materials of Jupyter notebooks. I already had, if you excuse me, I already had this example already run, so I will start working with this now. But in your case, you will start to entering in this directory and opening this file. But in my case, I will go to the run directory, and I will open this file, which is a notebook. Jupyter Notebook. I don't know if you are familiar with Jupyter Notebooks. Jupyter Notebooks is a format of code where you can mix documentation like this. You can see there is HTML documentation, and also there is cells of code. These cells of code can be or must be run by clicking on the run button up here, you can see, and there will appear here a number that means the ID of the run you have done. For example, you can click here and you will see that the cell is running, and now you have the ID of this run. And well, I don't want to spend much time on this, but as I said before, we are doing in this tutorial, we are presenting an analysis of El Niño southern oscillation. As you probably know, the El Niño southern oscillation is a large-scale warming event in the equatorial Pacific Ocean, and this is the switching between two main phases. Let's say that there is a neutral phase that is this kind of phase where the trade winds blows from east to west, so they drag, they produce a transport of surface waters towards the west. That means that in the east side of the equatorial Pacific, there is some upwelling conditions that produce a cooling of these waters, and in the west side of the equatorial Pacific, near New Guinea and Philippines, there is a warming of the waters, right? So this situation is not stable, it's not static, this is stable, has some variability from the situations that we call El Niño and La Niña. In case of El Niño situation, we have a weekend of the trade winds. That means that this mass of water, warm mass of water, cannot be maintained in the west side of the ocean. So this mass of water is transported towards the east, producing a warming of the east side of the equatorial Pacific, and producing also a cooling of the east side near New Guinea, and etc. And La Niña situation is almost the opposite, right? There is a strength of the trade winds. That means that leads to a bigger transport of warm water towards the west, and increasing the upwelling in the east side of the equatorial Pacific, right? And well, what we are going to, in this tutorial, we analyze these situations, and we do it programming in Python. Here, there is cells programmed in Python. You can go over the video if you want to have a clear explanation of every cell. You can go over the video. So we spend time explaining every line in every cell. Now, it's just to say that you have to click on the run button of every cell and see the results. And well, in this tutorial, we work with two different Copernicus products. We use the global reanalysis, the physical global reanalysis, because we are going to do an analysis of sea surface temperature. And also we use an OMI from Copernicus, sand monitoring indicator from developed and produced in Copernicus, that is actually El Niño index. Here you have the result of this OMI. It's just an index that gives us information about the situation of this oscillation. The positive values of this index are associated to the El Niño situation, and negative values of this index are associated to the situation of La Niña, right? Well, along this tutorial, we learn how to get the data of this OMI and how to plot how to plot this OMI, and we discovered that as usually occurs with Copernicus OMIs, they are multi-product. They are multi-product, so they are produced as ensemble systems. So we do not only have the values of the product, we also have information about the uncertainties of the product, because we have an ensemble mean and the spread of the ensemble mean. We learn how to plot the ensemble mean and also the spread of the ensemble mean, and we go further by plotting not only this, but also plotting the annual means in bars, right? So we start to work with this index in annual means from now on. With this plot, we learn that, for example, the year 1997 and 2015 was years of very intense activity of El Niño situation. And for example, the year 1999 was a year dominated by La Niña situation, right? And after that, we go to work to see what happened in the ocean in these years, in these specific years. And to do that, we download data from the reanalysis, physical global reanalysis from Copernicus. And this we go to download this data using the Copernicus Marine client. This is a very novelty in Copernicus services. It's a way to download data from Copernicus just using Python commands. So yes, I don't want to spend much time on this, but we code these lines that we use the function subset, a very interesting function from Copernicus Marine client, a function that enabled the downloading of data very fast, really fast, and very simple. You just have to know how to give the configuration of this function that maybe seems to be a little bit complex, but at the end is not as complex as it could seem, because as Leila said, you can get the information of this configuration from my ocean viewer. You also can go over the Copernicus data store web page, and there is a little button when you are trying to download a group of data. You define the group of data, the data set you want to download, and there is a button that the button automate. So you get all the information you need to fulfill these subset functions. So I think it's a very interesting part of this course. I really recommend to anyone who is interested in downloading data from Copernicus to go over this part and understand and see that it works really, really fine. And well, after downloading the data, we start to plot maps of anomalies. And firstly, we plot maps of anomalies just for specific years. For example, here we go over the years 1999 and 2015, and we code the Python lines needed, and we code some functions to plot maps of anomalies like this. So we can see the anomalies of sea surface temperature in Asia, also in Asia, associated to years with intense activity of El Niño and La Niña pattern. But we see here, we will discuss in the video that these results are not as good as we would like. And we go into the next section where we code how to plot El Niño and La Niña patterns. To do that, we use the El Niño index we plotted before at the beginning. We use this El Niño index, and we make a mean of the years that are dominated by El Niño, and we make a mean of the years dominated by La Niña, and we plot the anomalies of these two these two groups, and we obtain, oops, this section is not run. Well, it's removed. Well, and we plot the. Yep, we can go over this. Let's see, my. And well, as you can see, we in the tutorial we plot the specific patterns associated to the positive El Niño index and to the negative El Niño index. That actually the negative El Niño is actually La Niña pattern. Well, I hope you enjoy the tutorial, you learn things, and you find interesting information here. I think the downloading procedure is very interesting and very new in Copernicus services.
Thank you, Alvaro. Yeah, that's very interesting, and I hope that sparkled a little interest in our participants to go and explore the tutorial fully. We do have a few questions for you. I don't know if participants tried to do the exercise themselves, because some of them were having an issue, a technical issue. So first one, I'm just trying to, so here we go. The first question is when or why the OpenDAP connection through the Jupyter Notebook is deprecated. Are there other options if we want to manipulate heavy data?
Yeah, well, why the OpenDAP connection is deprecated? I cannot answer this question because, well, it's the politic of Copernicus services. Yeah, the other option to manipulate heavy data is the option you will find in the tutorial. Is they use the Copernicus Marine Client. Is very fast. Is for me, I think. I think I didn't expect that you can download very fast the data, and actually it works fine, and actually well, it's very simple. Maybe in the beginning may seem a little bit complex, but once you have the first configuration of the subset function, you have you are open a window to download a lot of data in very fast mode and very simple manipulating the differences. I recommend to this user to see the section in the tutorial about downloading data, because I think that's the way to do it.
Okay. Thank you. And then now there's someone who indeed found an issue. I keep getting this error when I try to open with OpenDAP again with OpenDAP. NetCDF, malformed, or an access file. I think it's the same problem. What does it mean? Or does it say something to you in particular, this error?
Well, is it malformed or inaccessible? Yep. This could be, I don't know in what section this appear, but maybe the problem is that the NetCDF is not in the system. I don't know if the user has already downloaded the data, or maybe I will recommend that. Well, it seems there is.
Yeah.
Let me find. I will share my screen for a second.
Sure, you can.
Here. Well, I think if you find some problems, sometimes this kind of problems can be solved by restarting the kernel of the system. You can click here in kernel, and you can click here in restart kernel and clear all outputs.
I can't see your screen, Alvaro. I don't think you're sharing. I can't see your screen.
Sorry.
No worries.
Now yes, right?
Yes, now it's good.
Well, so I said sometimes these kind of errors can be solved just by restarting the kernel. So you can click here in kernel, restart the kernel and clear all outputs and restart. Well, this will clear all outputs of the system, so you will lose all the figures you could created before. But well, it's not difficult to go from the beginning and running the cells and etc. Right?
Mhm.
Yes, you can go and click on the cells, etc.
Cool, thank you. The next question is more general. Do you have any link or experts that can chat regarding Python queries? Or if you have any questions related to our data and how to access it via using Python, you can contact our user support. But we also have a few articles already dedicated to this topic in the Help Center. Yesterday we had Cedric who showed you how to access the Help Center, and there you will find a few articles already dedicated to Python and maybe GIS as well, QGIS. Yeah, in our previous workshops, you will also find longer tutorials where you have deeper explanations on how to access it. And in basically every Jupyter Notebook tutorial, you will find information on this. But if you have a more specific question, yeah, don't hesitate to contact the user support.
Yeah, in the tutorial, in the sections, I think in the section of downloading data, I provide some links to the Copernicus Health Center.
Perfect.
Your questions about Python are related with the creation of environments of Python or environments and use Copernicus Marine client. I think in those links to the Copernicus Help Center, you will find also help and also ways to contact people that maybe they will help you.
Yes. And another question about your exercise. Do you have an example of analysis to analyze the correlation between ENSO and the wave height together? I don't know if it was something.
Well, it would be very interesting, actually. It would be very, very interesting exercise. I don't know. Actually, in the previous versions of this tutorial, we've evaluated the option to include the analysis of correlation in specific points in the map. But at the end, we thought it was quite difficult for users, so we decide to remove it. I don't know if there is any way I could provide these cells to the users.
Would it be an advanced level, you think? More like an advanced exercise?
Yeah, it would be some kind of it would be some way to provide extra material for people with, for example, for people who is interested in correlation analysis. We could provide the functions because they are already code. But well, I don't know if we have a way to
make it available.
Make it available.
I recommend the user, if you're really interested in that, you can contact the user support and we will make sure it gets available to them. I mean, if Alvaro, you're happy to share it, why not? I mean, we can definitely do the link between. So whomever posted this question, if you're available in this study, and Alvaro is happy to share it with you, just get in touch with the user support, the Copernicus Marine Service support, and we will make the link between you guys.
Okay.
Thanks for that, Alvaro. That's very nice.
No, it's something that is already done. It was actually a pity because we had all that material and we thought, well, this is too much for just birds, and we decided to remove from the material. So I think it's good if we can share this code and it's at the end it's useful. It would be great.
Yeah, no, that's definitely. It's basically a never-ending exercise, right? You can always add something.
Yeah, actually, this is the opening of a door where you start to analyze the El Nino, but this is a very actually it's very simple exercise. You can spend all your life analyzing the El Nino, right? So
Yeah, I can
there is people
imagine.
that works in that for all his life.
Exactly. I noticed, so to respond to a previous question on the OpenDAP access, just to let you know or remind you, yesterday we had Cédric Jourdain. He told you about how we are transitioning data. The marine data store is in a transition period. And so some of the data sets might not be available at the moment because they are being transferred or to another kind of platform. So some of the data sets might not be available for the moment, but at the end of March, this transition period will be done and you will be able to access all the data sets again. It might be related to that, the OpenDAP problem you were just mentioning before. I think for the Jupyter notebooks for now, we don't have any other questions. Yeah, I think we are good to continue to our next speaker. Thank you very much, Alvaro.
Thank you very much.
So yes, take your time to look at these tutorials and hopefully you will enjoy it. And our next speaker is Stefania Ciliberti. Hi, Stefania.
Hi.
Hi. So Stefania will tell us about the exercise she developed for us today, and will be the same topic, but using this time the QGIS. So whenever you want.
Okay. Thank you, Andrea. I start sharing my screen. Thank you, Andrea. Hello again to everybody. And with this presentation, basically, I'll go through the key elements of the exercise that we developed for the QGIS training session. And particularly, I will touch some key topics that are also recurrent in this first part of the training with the talks given by my colleagues before. So first, I will give an introduction to QGIS and the Copernicus marine products that we have been used. Then I'll move to a discussion on the implemented workflow that have been used for analyzing ocean data using QGIS, a brief summary of the main results, and finally some references that might help you in developing new exercises, but also learning more about QGIS. So the workflow is quite, let's say, straightforward, because we start from this specific training session devoted to analyze key processes in the Pacific Ocean, more in general in the Asian region. We started from the global ocean products that have been accessed, and let's say they represent our upstream data. So you have seen this morning, but also yesterday, very detailed presentation about the product catalog of Copernicus Marine Service. And for the global ocean, that is the key region that where you will find information about your specific areas. You have plenty of products from model, covering the three components: physics, biogeochemistry, and waves, to observations, including in situ and satellite. And of course, what we have learned to do through this training session is how to access this kind of catalog, browsing through the source if you're interested in models or observation, which is the essential ocean variable that you would like to analyze, and the temporal resolution. And through the MyOcean viewer, you have seen how easy it is to say refine the way you search and discover the data. So the Marine Data Store, the Copernicus Marine Data Store, through the MyOcean Viewer Pro, gives us tools for accessing easily the data and download them for the needed analysis later on. So as user, we are used basically to query the data store and then to retrieve some data that in this case will be given as input to QGIS. QGIS, of course, is a quite powerful, is an open source geographic information system that gives you some basic and advanced functionalities for analyzing data, particularly in our case for analyzing Copernicus marine products. So you have some basic, let's say, functions that gives you the opportunity to view the data, explore them, and let's say compose maps or create, edit, manage, and export data, depending on the analysis that you are going to do, and also analyze data in more complex, let's say, framework, calculating statistics. I mean, today you were asking, for instance, how to compute also correlation with QGIS is extremely simple, and I'll show you some, at least, which are the features that you can use for implementing such kind of statistical analysis. But of course, QGIS gives also possibility to develop new applications, publish new maps on internet, or specifically for your application, extend functions through plugins. And today we will see that QGIS has some dedicated plugins also for supporting you all in the retrieve and view of the Copernicus marine products. And if you are willing to also develop some Python codes, there is a Python console embedded in QGIS that is not explored in this tutorial, but could be so to do and give to you all as extra material if you are interested, how to code directly with Python inside QGIS. So all the details are accessible through the documentation that is that has been made available by QGIS community in the main website. In the first part of the training session, I gave some, let's say, in the dedicated video, some information about how to install QGIS. If you are a new user of QGIS, you have, as also Andrea was showing before, in the Copernicus Marine Learning material, you have a dedicated section that gives you information about how to access the code and how to perform the installation. And particularly, you have two ways for installing QGIS in your computer. Using the standalone installation that gives the executable, depending on the operating system, of course, that you are using, and gives to you the possibility to download the last developed version that made available to the community. In this case, is the QGIS 3.54, or still the long-term release, that is the version, usually used also for making developments. I mean, more, let's say, complete is the stable version of the software. And in this case, it's the QGIS 3.28 that I'm also using in these, I mean, in the exercises that I propose to you. But you have also an advanced installation through a dedicated installer that is OSGeo4W. This is for more advanced usage of QGIS. Particularly if a user wants to develop new, let's say, and also try new functions in QGIS, but also if gives the opportunity to have in your laptop multiple versions of QGIS that you can test. So this can be, for instance, a nice exercise if you want to test the exercises that I have been proposed through the video and developed with the 3.28, the stable version of QGIS, in the new version that is 3.34. Through this OSGeo4W, you can install both versions. They will not give any conflicts, and you can test the two and see also what are the added features in the last versions that might, let's say, simplify, for instance, some processes or some calculations that you would like to implement. So as soon as you have installed the QGIS, you have easily menu bar that gives the information about the different functionalities in the QGIS, and surely you will face somehow the need of working with vector data and raster data. So vector data are the most common feature in QGIS because they are georeferred information in space and time using points, line, and polygons. And this is the way we basically have the possibility really to exploit the huge amount of a geographical information system, because the vector managing vector layers gives us the opportunity to exploit tools for analyzing, for geoprocessing the data, for modifying the geometry, and more in general for managing geographical data in an easy way. On the other side, we have the raster, that are the matrix of pixels. So basically the image somehow that you take from the Copernicus Marine Service in terms of information, geographical and physical information of the field that you are downloading. And this gives also, QGIS gives also functions for analyzing, projecting also in different projections type, convert data, extract information from this amount of matrix of pixel, and somehow combine also, combining vector with raster gives you really the capacity of exploiting all the vectorial tools but taking the information from the raster fields. And as I was mentioning to you in the event page, in the e-learning material prepared by the Copernicus Marine Service, you have a dedicated section in the website where you can download, you have somehow some guidelines on how to start with your QGIS, how to download the software, how to install it. There is a dedicated video that I prepared for this scope, and also particularly the plugins that are supported by the Copernicus Marine Service for, and in this case, the one for accessing and for opening and analyzing the NetCDF files in a very easy way. And this might solve also some questions that I saw before raised in the chat. No, I mean in the sense on how to make this connection between the NetCDF file that has been downloaded through the Copernicus Marine Data Store with QGIS, and this is done through this plugin. Indeed, the plugin gives the possibility to, let's say, take the NetCDF file that you have been downloaded from the Marine Data Store, and with a very effective GUI, you can add it, the file that you would like to load in your QGIS project, and this will be displayed in the GUI, in the window that you will see as soon as you launch the plugin. And associated to each file, the CMEMS NetCDF plugin gives the facilitate also the presentation, the view of the variables that you would like to load and the metadata. So as soon as you have been selected the variable, you can add it as a layer in your QGIS project and browse through the timestamp, for instance, but also it's not visual idea, but also the depth in case you are managing a 3D variable, for instance, temperature, where you have also the information along the water column. And as soon as you have been selected it, this will be added in your project quite easily. And this is really powerful plugin because it's done specifically for managing in an easy way the Copernicus Marine products. Of course, QGIS gives the possibility through some standard, let's say, interfaces, the possibility to open NetCDF file, but taking this plugin and installing it, that is quite simple to do it, straightforward. You can easily start really to play with the Copernicus marine data. Additional plugins that I've been used and I found quite helpful for the exercises were the quick map service, that is a base map, basically gives us the possibility to add base maps and geoservices in your QGIS project, and Dataplotty, that is a tool developed, written in Python, that gives the possibility to plot charts, scatter plots, bar plots, and so on for visualizing easily some time series or scatter plots of your selected variables. And I'll show you some examples. So in this training, I mean, I was inspired by the work of Alvaro, and we decided also to show the other way of presenting and analyzing a physical event like El Niño in QGIS environment. You know, and in this, the first part, I mean, of this short presentation gives you some elements on how to compute SST anomalies for monitoring, for instance, the El Niño event evolution in a specific region or in the whole area of your interest. We will see also visualize easily the Copernicus Marine products in some specific points, and QGIS is quite effective in doing that. Also, if you would like to start to do something a bit more complex in terms of statistical analysis, I'll show you how to easily interpolate different fields, like, I mean, in this case, the sea surface temperature, but given one from the global ocean forecasting system and from observation. So how to manage basically two different products that are coming their own resolution and interpolate them in the same way. But go step by step by presenting the upstream data that we have been used in the QGIS exercise. The first one is the Global Ocean Analysis and Forecasting System for the physical component, that is the produced by the GLO MFC, the GLO Monitoring and Forecasting Center, particularly by Mercator Ocean International. And here we selected specifically 3 types of datasets. The first gives the daily mean of 3D temperature and salinity for a specific period, in this case just a week. The 2D mixed layer depth, again for the same week of analysis, the first week of November in the Indian Ocean. And the last dataset, that is the monthly mean computed by the Global Ocean Forecasting System between June and November, when we started to, let's say, monitor the last El Niño event occurring in the Pacific Ocean at a specific depth, the first layer of the model, and for the overall global ocean. The second product that we are going to use is the Global Ocean Reanalysis for the physics. In this case, we accessed only one dataset, that is the climatology, the monthly climatology computed considering the overall time series from 1993 to 2016 made available by Mercator Ocean International through the Copernicus Marine service. And in this case, again, June to November, because these are the needed data for computing the SST anomalies, as we will see soon in the later slides. The last product that I'm proposing is the sea surface temperature, the satellite observations. In this case, this is a product provided by the SSP Thematic Assembly Center. The production unit is at Ifremer in France. And here we access the available dataset that provides the daily satellite L4 sea surface temperature for the first week of November for the Indian Ocean. In the dedicated tutorial, or let's say user manual, that I made available for the QGIS exercise, I have been also provided to you the way of accessing the Copernicus Marine, these products, so the Global Analysis and Forecasting System and the SST satellite observation by using the Copernicus Marine client. That is the very last an important update from the Copernicus Marine service for easing the access to the Copernicus Marine catalog, and through the MyOcean Pro. So you have the examples of the upstream that I used for this exercise, also with the two new ways of accessing the data. So it's a complementary information to what Alvaro is providing in his Jupyter notebook, and Leila, for instance, was presenting before at the beginning of this session for the Copernicus MyOcean Pro viewer. In this case, we focused our attention on El Niño event in 2023, particularly the event that started in spring 2023. Mercator Ocean International, through its periodic bulletins, provide a description on the evolution of this event in the website. So here you see a snapshot of the bulletin that was released in December, analyzing what's going on in November 2023 in terms of anomaly in the Pacific region. And that was somehow the element that gave to me the inspiration to redo the same kind of exercise, but through QGIS. And this is extremely simple, because we can calculate the SST anomalies by combining, let's say, considering two upstream data that I was showing to you before, the SST monthly means provided by the Global Analysis and Forecasting System, and the monthly methodology provided by the Global Reanalysis. And by simply computing the difference between the monthly mean and the climatology, we have computed the anomaly at a specific month for the sea surface temperature. How this simple workflow is through QGIS? This is done through the Model Designer. That is a tool that gives the possibility really to build the workflow that you would like to run. And here you can think that this is an extremely powerful tool, because it gives to you the possibility to compute even more complex formulas in an easy way. And you see how really straightforward it is to go from our workflow to the Model Designer. And in this case, for computing the difference between the monthly mean and the climatology, we use the raster calculator. The raster calculator is the element, the block, the object that performs calculation on the basis of existing raster values. This was extremely helpful, because as soon, and you will see in the video, that as soon as you load on your QGIS project the sea surface temperature provided by the reanalysis, what is here called the theta clim, the sea surface temperature climatological fields, and the ones provided by the near real-time system, by running automatically this graphical modeler, you have the calculation of the sea surface temperature, as you can see here. So here you see basically the the SST anomalies for the period between June and November 2023 in the global ocean. And of course, you can also, as done in the bulletin, characterize the Niño 3.4 region. That is the key region where we are used to evaluate the climate impact and signal in the Pacific Ocean of the El Niño event. And this is, to extract the information specifically in this region, we can easily implement another workflow that through the SST anomalies, once defined the bounding box of the region, that in this case is the purple one here displayed, you can invoke a specific function that is called clip by masker layer that extract the information of the sea surface temperature anomalies just in this region. And if you would like to add a bit of complexity in your calculation, and for instance, if you are interested in this specific purple region, you would like to know what is the mean SST anomalies along the period, or per specific months, you can then ingest this intermediate output in another function made available by QGIS, that is the zonal statistics, and returns the metrics in your region. So quite easily, this is the steps that I was showing to you before. So as soon as we have computed, extracted by clipping in the region the SST anomalies, we can compute the metrics in a quite easy way by selecting the layers that contains the anomalies in the specific region and doing because these are, of course, as you can see, different layers that you can, by selecting the management layer, compute and access the computed metrics through the zonal statistics as in the attribute table of the output layer. So this shows basically the very last step, that as soon as you have the single fields with computed zonal statistics for the NINIO 3.4 region, you can merge all this information, combine them in a unique data structure, and returns the matrix with the basic statistics like means, minimum and maximum value, variance. But you have also many other options, as I have been showing you in the video, for characterizing the evolution of the SST anomalies in the NINIO 3.4 region. Another way to use QGIS is to select some locations and extract the value of the essential ocean variables that we have ingested, in this case, sea surface temperature, sea surface salinity, and mixed layer depth in some specific points. This is done through a specific function in QGIS that is called sample raster values. And these sample raster values basically extract as soon as you provide a raster, so the field, what has been translated from the netCDF to the raster layer in QGIS to this function, it gives to you an additional layer that contains basically the values of your essential ocean variable in some specific points. This is the example that I was proposing in the video, so in 4 different regions in the Indian Ocean, and basically you can see here that as soon as you extract basically the information for the SST, you have in the 4 points the corresponding SST value for that specific day at that location. And of course, if you use the graphical model that I was showing to you before, you can automatize this kind of simple exercise for this week of interest that you are analyzing and that I was proposing. And in this way, it will give to you the evolution of the sea surface temperature at these 4 specific points, but along the time. Another nice exercise, interesting, I mean, at least to open some opportunities for doing more complex evaluation, is what I'm proposing here in terms of evaluation of the SST in the Bay of Bengal. This is a bit more, let's say, it seems complex, but in reality it's quite easy with QGIS, because we first need to evaluate the SST, so the sea surface temperature as given by the Global Ocean Forecasting System and the satellite observation. We first need to access, of course, the upstream data that I was showing to you before. But the SST observation, the satellite, is given in Kelvin, while the SST given by the model is given in Celsius. So the first thing to do is to convert from Kelvin to Celsius the SST satellite observation. And this is done through the raster calculator quite easily, giving the input field, implementing basically the conversion, the input field minus 273.15, that is the conversion factor to go to Celsius, and the raster calculator returns the value of the sea surface temperature in Celsius. Sometimes in this presentation you see this special symbol, run as batch process. The run as batch process is another quite powerful function of QGIS, because you, in principle, the raster calculator can work with one raster, but if you have more than one raster, 10, 100, for instance, you can run it in parallel somehow, in batch mode. So the same formula can be applied to all sources that you have in input. And as soon as you have computed the SST in Celsius, you open also the sea surface temperature given by the Global Ocean Forecasting System, the one that I call SST Daily. And by defining a grid that I'll show you, you can use the QGIS for interpolating both sources, observation, and model in the same grid by using this function, add raster values to points. The output is basically the sea surface temperature given by the model and by the observation at specific grid location. And this is basically the representation in QGIS. So you have your input fields that are the grouped layers in green refer to the SST observation. The light blue group of layers refers to the model data given in their own resolution. We have also the grid that is this box in the Bay of Bengal that is, let's say, identified by the centroids. And by running this function, add raster values to points, that is accessible through the toolbox of QGIS, the output you will see in your project is basically the SST from both sources in these points. And from this point of step on, you can start computing bias, so the difference between model and observation, so supporting also the validation, for instance, of the model data using the observation, but you can also compute correlation, you can compute more, let's say, complex but meaningful metrics that support your analysis. And this is, for instance, a typical scatter plot that can be visualized with the data plotty and exported in CSV and imported with Python, and you can continue to play and make more sophisticated analysis even in Jupyter Notebook. So you see here the way of extracting the information is extremely powerful through QGIS. All these exercises, of course, here I show you the main functions, but the overall explanation of the exercises are given in the video and also in a dedicated PDF that contains the steps from the access until the visualization of the output of your data. And as a summary of this presentation, as you have seen, and I hope that the exercises will help in this sense, QGIS offers really capacity of analyzing in an effective way Copernicus marine products by using the available plugins made available by the Copernicus Marine Service, and also exploiting really the capacity of this powerful product catalog that provides to you a wide range of products that can fit for all your, let's say, needs. If you are interested in analyzing with such kind of tools an event or a process, a physical process in your interested region. We have seen how raster graphical model gives the possibility to execute automatically numerical algorithms. Through QGIS, you have really possibility to extract in an easy way values from an assigned shapefile over an assigned shapefile that can be, in the example I show you the points, but can be polygons. You can build transects, for instance, if you would like to, if you are in a harbor and you would like to monitor, for instance, the water quality conditions by analyzing the chlorophyll data measured in the coastal zone by using action of values from a raster on an assigned shapefile, you can build your sections and interpolate and then extract, more than interpolate, extract in this case the chlorophyll data in that transect. This is another example on the usage of QGIS in this sense. And with a grid, if you design a grid with a specific resolution that you would like to use, and that is basically just limited by the capacity of your computer in terms of computing time with QGIS, but in principle you can have also high resolution grids, you can easily interpolate Copernicus marine data in your target grid with different methods, starting with the bilinear and going to the bicubic, but also more sophisticated kind of interpolation, and continue your analysis of the data. Here there is just a list that is also present in the manual, in the PDF that was made available with the video about QGIS and all the Copernicus Marine Service sources that have been, let's say, used and where we have been contributed, as well as the CF conventions and the NetCDF data model that is recurrent in our experiments. So I hope you find these videos and also the presentation helpful, and I thank you all for your attention.
Thank you, Stefania. Yes, that was really nice. I hope that gave some more intel to our participants, and don't hesitate to explore these materials that are available already, and you will be able to rewatch Stefania and Alvaro's presentations, so you can maybe get more answers to your questions. And now we have a few questions for you. Let's see. The first one is more on your opinion, or your based on your experience, but which one would be the best to visualize and analyze data, QGIS or Python?
Well, it depends really on the usage on the usage of the data that you would like to do. I mean, if you are more interested, of course, in doing analysis in a more effective, I mean, in a more complete way, by exploiting functions, statistical functions, but also let's say way of manipulating the information, and you are more used with Python. Of course, Python has a wide range of opportunities for displaying data. What is powerful in QGIS is the fact that, as you will see in the video, and somehow I was trying to communicate in my presentation, with QGIS and with the Copernicus plugin, it's quite straightforward. I mean, if you would like to do an easy check, fast check of what's the sea surface temperature pattern in your region, and you download the data from the Copernicus Marine Data Store, and you simply launch QGIS and import in 1 second, you do without writing any command line, I mean, without programming. Otherwise, with Python, of course, you can do things much more, let's say, sophisticated, also in terms of kind of visualization, and that, of course, needs some code. But on the other side, with the Python console, that was not shown in this tutorial, you can somehow combine the capacity of QGIS on being somehow effective in the visualization with the advanced solutions provided by a code written in Python.
And
it depends on your usage, of course.
There's actually a question related to that. There was someone asking us also, can we add QGIS to Python so that we can run both together? I don't know if that's what you means by...
Well, yes, in the sense that you can, some how can I say, libraries that I just saw some examples. I never developed this kind of, let's say, interfaces, but you have the possibility also to embed in your Python code the launch of your QGIS project, as well as through the Python console. I mean, layers a bit more advanced, maybe we can think also on exploring this possibility if users are interested. But definitely, I mean, the two can communicate. I mean, it's just a matter of understanding with which library and how to properly code it.
Yeah, that's very interesting. And this another question we have is related to can you use QGIS to calculate the model resolution of a specific area? Reanalysis is 112 degrees, but is it everywhere in the globe?
I try to give some understanding of your question, in the sense that let's from the first, if you would like, for instance, if I'm understanding correctly, you would like to calculate, I guess, on another grid, but in a specific area, like what I was showing you before, interpolating in a specific target grid with QGIS, you can do. I mean, you start from the global forecasting system, for instance, that is at 112. And you say, okay, in my specific region, I don't know, in the Maldives, I would like to interpolate the global forecasting dataset at 148. So increasing the resolution, because I would like to specialize the visual more high resolution in my key area. The answer is yes. With QGIS, you can do quite easily, using the same philosophy I was showing to you, defining a grid, get the resolution, and using the functions for extracting the raster value in your target grid. And of course, the second question, reanalysis is 112, but is where in the globe? The answer is yes. The global ocean physics reanalysis is for the whole globe, of course, at the given resolution. So you might expect, for instance, that very close to the coast, you might have a certain degree of approximation, because the model is not really seeing that kind of resolution. I don't know if I answered to the question.
No, thank you. I think so. Next one would be, is it or can we use WMTS to add raster data to show in QGIS? If this is clear.
Honestly, I never. So this is a good point that maybe I need to check. I don't have an answer. I'm sorry about this right now, but in principle, I mean, assuming that QGIS is quite is prepared to ingest different format. For this specific one, I don't know, but for the majority, yes. We can check and give you back an answer.
Yes, I also wanted to remind you all that obviously we didn't address all the questions that you have posted, and thank you very much for your questions, but we will try to answer them, and we will make them available in the same page we showed you before with all the materials, so the events page. So the answers will be posted there as well, so you can find the answers to your questions later. And so yeah, maybe we can try to also find, for example, the answer to that one.
Sure.
Thank you. And I think we have a few more. So this time related to, does the NetCDF plugin via QGIS take any NetCDF type? For example, curvilinear, or is it only deals with regular types? Or is it more the other way around, right? Only for nets.
One from the test I have done deals with the regular types, in particular the ones, the CF, that follows the CF conventions. I guess that maybe is it in the plan to have some more options in this plugin? But of course, being a plugin suited specifically for the Copernicus product, at the moment it deals with only with the regular grid. Maybe in QGIS there are possibilities to import any generic NetCDF that was not explored in this case because we were more, let's say, focused on using the Copernicus Marine products. But maybe if you have a look on the native, let's say, NetCDF library in QGIS, maybe this can be helpful for you. Surely this plugin deals with regular grid only.
Okay. And another one. There's another question related to WMS. Can we sample raster value with WMS?
I don't know if this is more a question related on the access through the Copernicus Marine Data Store, and I because I mean
not necessarily for QGIS, right?
Yes, more than this, I think.
Okay.
Because WMS was a way of accessing the data through the Marine Data Store, but now we are somehow evolving, and maybe these are possibilities that can be, I don't know, deprecated. Yeah.
Gael and Leila, if this says something to you, if you would like to come in and if you have any information on this. Gael?
Yeah, you can ask us. You can just contact us because at the top of my head, I don't know. But contact us and we'll answer you.
Okay, thank you. Great, thank you. And we do have, there's another. How to download multi-location raster time series data using CSV file. I'm not sure what R's mean in this case, but.
Me neither, but maybe this is something connected to the MyOcean Pro.
Oh, okay.
No, because it gives, I guess, because.
I guess, yeah, raster. Is it
maybe it's raster time series, so I don't know if you would like to take, for instance, in one point the home water column and you would like to export in CSV. This sure possible through, I mean, as Leila was showing before, through the MyOcean Pro viewer. And then once exported in CSV, you can open in Python, or you can even open in import also in QGIS, because it's a standard format. So depending on the usage, you can then use it. But for the download, well, I think yes, in principle, but I'm not the right person to answer.
Okay, if Leila or Gael, you would like to comment on this on the side of the viewer, if this makes sense for the viewer.
With the viewer, I'm not sure, but you can do it using Python, anything. We have article on this, so yes.
Well, yeah.
Of course, also with the client, of course, we can also do. Yeah.
Thank you. And yes, it's true. A lot of these questions you might be able to find the answer in our help center articles. Yesterday, Cedric showed you how to access it, but in the events page, you will also have an access directly to the help center where you will find all these articles. So we have answered this one. Trying to see. Maybe you would know this one, Stefania. Why the NetCDF plugin does not work for Linux? Would you know if it works for Linux or not? I don't know if you have.
Don't know, because I tested only for Windows, honestly.
Windows, right? Yes.
But maybe in the documentation for the plugin, maybe we can find. I'm sorry, I just did with Windows, so.
Yes. If it's not possible to access it with Linux, maybe it's something we could then.
Maybe it's because in theory it should be if I'm not wrong, should work. I mean, it depends on QGIS is supported in by Linux. I mean,
Linux.
also Linux can also QGIS can run also in Linux. So in theory, the plugin rely on the version of the
QGIS directly in Linux.
yeah. If you have been the user has some errors or I have to say the truth that I didn't check it with Linux because I have a Windows machine.
Sure, it's your experience. I don't know, Gael or Leila, if you would know the answer to this one, if it is possible to use it with Linux or not, or maybe we also cannot
No
decode
idea.
it. Yeah. Yes. You can if you're having trouble using the plugin using Linux, maybe you can also contact us and we'll maybe have an answer for you. Thank you. Do we have a few more questions for you guys? We did have a question for maybe Alvaro again, which is here. There were some Jupyter Notebook questions that pop up later. One of them is, do you perhaps have an example via Jupyter Notebook that illustrates how to transform the altimeter wave data into gridded data for easy model validation? I don't know if you remember ever doing
The altimeter wave data is data from satellite, so I think it is already gridded. But I think, well, the first answer is not. There is not. As far as I know, there is not an example that allows to the user to adapt two different grids. It would be an interesting exercise, right? To find a way to adapt two different grids, one over the other, to find differences between products. But no, currently there is not an example about this, I think.
Yes, a specific tutorial or something. Yes.
Yeah, that would be a very interesting exercise, yeah.
And I think we had another one for you, if I can find it. Not anymore. So there was a general questions on whether it is free for companies or if there's any restrictions in using the Copernicus Marine data, and how do you handle publications, for example, when you use Copernicus data. All the Copernicus services provide open source and free data, so you are free to use it. And in your publications, of course, you will need to cite that you have used the data from the Copernicus Marine Service or any other service, but there's no restrictions for you to use the data whatsoever. So that is good. And I think we are pretty much done with questions specifically for you guys.
Great, thank you, everybody.
Yes, thank you to you, Stefania, and to Alvaro, and Leila and Gael for being here and for answering all these questions. I see you still have a few more general questions. We will answer them and post them in our events page. We hope you enjoyed this webinar, yesterday's and today's. The next webinar will be focused in America, the American continent. And we will also have Alvaro and Stefania with the new tutorials. Feel free to explore all the materials we have made available. The replays will be also available very soon, and you will also receive a certificate of participation. And if you have any other questions, don't hesitate into contacting the user support, as we said before. Thank you very much, all of you, and have a good evening or day, depending on where you are. Thank you very much. And bye. See you in the next one.